Okay, so let's get into our JSON stuff, the JSON version of our program. So for starters, and we're still going to operate in this file test for at least a little bit longer. And I think I mentioned last time I won't give you homework over the weekend. I will, if you want, let you keep working on the assignment that some of you have been updating. I'll let you turn that in on Monday because I know that people are spending quite a bit of time on it and working hard on it, and that's going to lead to learning. But I also don't want to penalize you for, you know, you actually putting in effort. So if you want to keep working on it until Monday, that's fine. I'll adjust the due date, or actually what'll be easier for me is for you just to put a note in there saying that you're submitting this, or, you know, whatever, with some changes. But I won't give you a new assignment over the weekend, so folks can hopefully play some catch up with real life. I know some people have errands and things like that they're running for family members who are a little older and that kind of stuff. So give you the weekend to catch up on other things. Okay, so what I'm gonna do here, last time we were talking about, we saw this little error here at the end about the JSON serializable thing, and I want to actually draw a picture here to kind of give you some context on what we're trying to accomplish. I think that might help us maybe see the larger picture of what we're trying to do here. All right, so we have our dungeon crawler here. We'll just call it our game. we have our game here, and our game governs, or, you know, controls a map. Let's actually put it underneath this guy. So it controls a map. All right. And originally, what we had is we had our map with hard-coded rooms. All right, so we had rooms hard-coded into our, here, we'll make yellow, that's code, something like that. All right, so we had our rooms all hard-coded. We had our rooms and our exits, and we would hard-code them in there. And that was fine, it worked, and we had a game that was functional, you know, had some features in it. But hard-coding those things was, you know, starting to become cumbersome, you know, and if we were going to make our map much larger, that would become a problem. All right, so, you know, this was version 1. So what did we do to upgrade from that? What we ended up doing is we moved our rooms to a proprietary, can I spell that? Proprietary file format. Stretch this out a little bit. All right, so we invented a file format here that we then read rooms in from. So these guys were linked to generate our map from this guy. And then we said, you know what, this proprietary format, it's fine. It gets the job done, but it's pretty particular in that, you know, we add one extra little space, it breaks, and things like that. Plus, if we were to, you know, as we imagine our multi-billion-dollar text-based Python game industry that we are inventing right now, 40 years past its prime, as we're inventing this, we might say, you know what, if we want to have some other big players come in and work with us on this, and maybe have some, you know, their own maps or third-party things that they're going to add to it, we probably want to pick a file format that is going to be something that is common to all of them. And I kind of make this akin to like picking a natural language. You know, when you make a phone call to somebody, you have a job interview, you and that person agree on the language that you're going to be speaking on the interview. Now, most of the time that isn't an actual discussion you have. If it's something in the United States, you just assume it's going to default to English as the language you're going to use to communicate thoughts to each other. And realistically, more worldwide now, if an American is involved on the phone call, probably English is going to become the default language. But regardless, the geopolitics of that is insignificant here. The point is that there's a language that both parties both understand and have agreed to speak to communicate with each other. As opposed to, this might be like, I know some made up language that I invented at home. And when I have a job interview, I say, hey, let's use the Mike Littman made up language to talk. And they look at me like I'm crazy because they don't know that language. So I can either try to teach it to them before the conversation, or we can agree upon a language that both of us kind of understand. So we decided that, and actually here, what I'm going to do is I'm going to hard-coded rooms. So I'm going to kind of put our past attempts up here as reminders of what we tried to do. So we replaced hard-coded rooms with reading rooms from a file. So some folks have asked, well, what's the purpose of file I/O? Well, it allows us to store our representation of our dungeon external to our program. And then when our program launches, we read in that file and get the updated the rooms. It also allows us to have our program in one place, our logic in one place, and our data in another place. I'll just use this opportunity real quick to introduce something called design patterns. Remind me, have you seen this this phrase before? Have I talked about it at some point in the slides? Does anybody remember it at all?
No, we haven't.
Okay, thank you. I figured not, because this is the first time we're kind of stumbling upon it. So I'm actually going to introduce a famous design pattern to you here. So the idea of a design pattern is a proposed good solution to a common problem. Okay, notice I put good and common in double quotes here because academics love these. If you've ever heard the phrase publish or perish before, in academia, I mean, Concordia is a teaching university, but I'm a research faculty at Concordia. So I'm probably, that means that part of my load is to do research and release, papers and go to conferences and things like that. Well, there's all sorts of proposed good solutions to things, and a common problem can mean all sorts of stuff. So the reason academics love these is when we publish a paper, the paper doesn't have to be for a good idea. Research means that we are advancing the subject area somehow, and that could be us saying, hey, I tried this and it doesn't work. And that means we have advanced the research area because we've shown something that isn't a good idea. So a couple of the, let's call these funny requirements of design patterns, is they must have a weird name, and they can be almost anything. All right. Now, having said that, we have a whole bunch of design patterns out there. And as an example in real life, you can decide that, let's talk about like maybe peanut butter and jellies. If you're going to make a peanut butter and jelly, maybe there's 2 or 3 different approaches on how you might make a peanut butter and jelly efficiently. Some people, they might actually spread the peanut butter on one piece and put the jelly on another piece, and then gently put the bread together. Other people might just kind of dump all the ingredients on one side and then put the bread on top and kind of smash it and let that spread it around. Whatever, you can take that to, umpteen different solutions. But punchline is there's lots of different ways you can accomplish making a peanut butter and jelly, and what you say is a good solution might not be something another person agrees with, but it's still an idea that might work. So that's the concept of design patterns, and the reason academics like these, it's a easy way to get a publication, because you just have to come up with a weird name, a problem, a quote common problem that you're trying to solve. But what does common problem mean? A common problem for Lockheed Martin might have something to do with missile tracking or jet engines or something like that, where a common problem for the everyday person might be making a peanut butter and jelly. So common problem can mean a lot of different things. But as you might imagine, through lots and lots and lots and lots and lots of different publications, a couple of these design patterns have kind of caught on as being important, good ideas, very related to the software development industry. And the first one we're going to look at that's starting to be related to what we're talking about here is something called MVC. And this stands for Model View Controller. Now, an important thing, let me throw this on the design pattern side here. A design pattern is an idea, not an implementation. All right, so for instance, we're about to talk about MVC, and Android has their approach to this. Apple with their iOS has their approach to this. Windows with .NET programming has their approach to this. They all have their own implementation of this idea that is the MVC design pattern. So Model View Controller says it is a good idea to keep your code, data, and interface in different places, i.e. different files, and have some way for them to communicate with each other. Now, we're only seeing the very, very, very beginning of this right now. We'll see it some more next semester when we start looking at some graphical user interface programming with Java and C#, doing some Android stuff. But for right now, at the very least, we have our logic in one place and our data in another place. It just so happens that our interfaces are all text-based, so there's not a whole lot of design going on here. So we're not really dealing with the interface side of things yet. All right, so this just says it's a good idea to keep these things in separate places, so that when we want to add something to the data that drives our program, we put that in one file. When we want to add something to the logic that drives our program, we put that in a file. And then if we had a user interface, we wanted to change the way the screen looked, we'd have that in a different file. And then we'd have some way of bringing those three files together to make sure they can communicate with each other. Because as you might imagine, if you have like an Android application or something, your logic might update the label on some screen. So you need your logic to be able to talk to the interface, but you don't necessarily want all those lines of text, lines of code to coexist in one document, because they'll start getting very messy. All right, so if you think about MVC here, it's kind of common sense, right? If you have three different things that are solving different problems, but they do have some overlap where there needs to be some communication between them, it might make sense to keep them organized in three separate places and then create a facility for them to talk with each other. That's what MVC is. It's the idea that that's a good idea. All right, and then how we implement MVC is up to the technology we're using, or if we're inventing the technology, then we might choose to create that communication channel between our interface and our logic, or our data and our logic, so on and so forth. All right, so right now MVC should be a pretty vague idea for us, because we're not going to be able to see yet until next semester, let's say, an implementation of MVC in action. But what I'm getting at here is our little model here is starting to have us stumble into this idea that you know what, rather than having all my data, my design of my map, the information about the rooms and the exits and things like that, rather than having that all in here sitting right next to my logic, why don't I go ahead and put that in a file and then have this guy read in that file? That's how he's communicating with the data in that file to get that data in there, so that when I'm looking at this stuff over here, what I'm looking at is the logic that's working with room and exit objects. I'm not looking at my proprietary file format, or more recently, the JSON format for this data file. Okay, questions about that concept? Okay, and you could even make a note, and when we go over the final exam, I like to go through the slides. I'll tell you what's important and what's not important. I very likely am not going to ask you specifically about this, because this is a major player in what we talk about next semester, and we don't have a real strong connection to it right now, but we're starting to stumble upon maybe why that idea exists right now in our little invented game that we're creating. Okay, so that's why I kind of initially introduced the topic right now, but it's not something that you should be overly concerned with right now. Just kind of know about its existence, and it makes sense because we're seeing it in action right here. All right, so, but we decided, you know what, this format for our file that we just made up, while it solved the problem for us locally here, and you know what, if we were the only ones ever working with this and we didn't have any dreams of expansion or other people coming in that we had to teach our made-up language to, maybe we can continue to use this, not a big deal. It would be equivalent to like opening a business here and then just deciding that you're going to use your made-up language as the communication language at the business. So what's the disadvantage of that? Well, when you hire a new employee, you're going to have to teach them your language instead of relying on a language that's more commonly known among lots of people. All right, so our proprietary file format that we had, it solved the problem, but we decided, you know what, not good enough, or we can do better. So then we decided, you know what, let's pick a file format that is common in industry. So we have something called JSON, which is the JavaScript object notation is what this guy stands for. So that is a syntax for representing data. So this is our data representation language. And this will allow us to follow a standard for describing our rooms and describing our exits. All right, so we decided, you know what, let's go ahead and let's use JSON here. And then we even saw a benefit over on this side, because originally when we read in rooms, we had to write that code that read in our proprietary file format. And we would say, okay, well, I expect the title first, then I expect the description, then I expect a whole bunch of exits until I run out of exits. So we had to write that custom code that knew exactly how to speak the language of our proprietary file format. Where now we're saying, you know what, because we've picked this industry standard language, JSON, I can now use a tool that's available in Python, it's available in Java, it's available in C# and Objective-C. Pick your language, there's a JSON parser, okay? Because JSON is a common standardized description language, data representation language. So we were able to use this JSON library to read in a JSON object from this JSON file, okay? So that made this more streamlined because we could use a tool to read it in. The way we described our data here was now more consistent, although from the questions I had related to the homework is this here is where our current struggle is. You know, we kind of recognize that, you know, what JSON is, but we haven't quite wrapped our mind around how do we write JSON? We get it if we see it, but to write it ourselves can be a little bit sketchy. So with that in mind, what we started talking about last time is, you know what, we can write this by hand. if we want, but JSON's a little bit quirky to write by hand, but we could write that by hand. What's important is it's an accurate JSON format, and it has to be an accurate JSON format because we're using that JSON library over here to read it in, and he's going to rely on this guy being accurate, right? If you walk into a room and you are speaking, you know, something that's not quite correctly formatted English, you know, an English-speaking person might miss some of your thoughts, might miss some of your ideas, or might not be able to understand you very well at all. All right, so we want to be speaking the proper version of this language in order for us to accurately communicate with this guy over here. And if we've written bad JSON, then we might get some errors over here, and we might think, oh, it's something with my logic, but it's not. It's actually something with your data. Your data is not properly formatted JSON, so when you go to read it in, this guy is dying because he's reading in, you know, it's garbage in, garbage out. You're giving him bad input, and he doesn't know what to do with it. All right, so one option is we can write this by hand, which is completely doable, but a little bit tedious, let's say. Or we can actually create a separate computer program. So maybe this is our map builder program. And our map builder program communicates with the user allowing us to tell it about the rooms and tell it about the exits and how they link to each other. And what it does is it, you know, maybe has logic that asks about rooms and exits. And then ultimately converts those objects into JSON. So maybe this program over here, this is a separate program. Maybe this program writes our JSON file, and this program over here reads our JSON file. Now, a human being can choose to write this JSON file by hand as well. One way or another, this file has to be created. It could either be created by this guy over here and updated by this guy over here, or it can be created and updated by hand, but it has to be accurate. Must be properly formatted. All right, so it has to be accurate. That way, this guy who is expecting you to be speaking proper JSON can read in that information. All right, so this is not a requirement. This is a power tool for us. Okay, think of this kind of like voice dictation. We can either write our papers by hand, typing, or we can voice dictate our papers, presuming perfect accuracy, even though sometimes, you know, our voice dictation doesn't write our words perfectly. We have to go back and proofread it, but let's assume it's perfect. This is kind of like voice dictation that is turning what we're saying into a certain format. Typewritten text, or in this case, JSON. But we could use the keyboard and type out the text ourselves. Any way you cut it, this guy should be correctly written syntax. In real life, we can say, well, you know, English is a little bit fluid, so you know, sometimes grammar can be a little bit suspect, but if a human is reading it, they can probably understand what we're meaning as long as we're in the right ballpark. You know, our thoughts are roughly, or sentence structure is roughly put together in a reasonable way. Whereas in the programming world, we need to be completely unambiguous because computers are dumb, right? Computers, they're not going to read between the lines like a human being will. You need to tell them perfectly what you want them to do, and you can't have syntax problems. So we might say, you know what, we're going to be fairly error prone if a human being is writing this by hand. We could do it, especially on a small scale like we're dealing with right now, but it might be handy to have something that actually outputs that for us over here. So this is a computer program. This is another computer program. They are both interfacing with this single file. One of them writes the file. One of them reads from the file. All right, so this is kind of the direction we're heading here. And what we've done is we've kept upgrading the idea of how our data is stored. So at the end of the day, this guy here is our data storage, where over here is logic, over here is logic. They're in separate places, hence our idea for the MVC design pattern. Keeping these things separate allows us to solve separate problems. I'm solving the problem here of having properly written JSON. I'm solving the problem here of outputting properly written JSON. I'm solving the problem here of inputting properly written JSON, turning it into a map, and then letting my user run around and kill rats and stuff like that. All right, so hopefully that puts it in a little bit better global context. Kind of my approach here has been give you a little, have you struggle with it, see what works, see what doesn't work, get frustrated, come back, give you a little more, so on and so forth. So that goes way back to the very beginning of the semester when I said you have to put in the reps. And me sitting here and feeding you all the information on all the code might be great from a getting it to work fast perspective, but isn't so great from a learning perspective. So in any case, that's the punchline. So are there any questions about this right here?
Is the motivation for doing this to be more organized?
I think that's one. Motivation is to be more organized. I think it's also to be less error prone, because you can imagine as this side over here gets more and more complex, if we were still hard coding our rooms and our maps started getting bigger and bigger and bigger and bigger, you could imagine that this guy would start getting pretty messy, right? Where now we can have that mess contained here in an organized format, and then this guy just reads it in. So, you know, we can all say that programming is hard enough as it is. So the last thing we want to do is have to juggle with our logic as well as our data representation in the same file when they're really solving different problems. Data representation is maintaining our information between runs of our program, where the logic itself is just operating on those objects. It's operating on rooms, it's operating on exits, it's operating on players. And that's enough for us to grapple with over here, is operating on those objects. That if we can store the mundane data associated with it, which is every bit as important as anything else, but if we can store that someplace else, we make this guy a little bit of a cleaner playing field, if that makes some sense. Does that kind of answer your question?
Yeah, thanks.
And I guess I'll throw one more thing out here related to this, is this goes way back to the original book we were using in here, where we're saying automate the boring stuff. So now that we have this budding skill as computer programming, we're wielding this tool. Now we want to think about ways we can wield it more efficiently, or wield it in a way that we're less error prone. And you know, because eventually what will happen is you'll be able to write code that is relatively error free right off the bat, or you'll very quickly get the bugs out of it because you've organized your approach to solving the problem in a cleaner way like this. And you can connect this to your real life experiences, right? You know, if you are solving some problem at home and as the problem gets more and more complex, how well you prepared to start solving the problem becomes more and more important, right? So, you know, if we think about something that's maybe time dependent, like cooking, you know, and you're making something that requires, 7 or 8, 9, 10 different ingredients, and you don't have all the ingredients laid out, you haven't made sure you have them in stock, things like that, you don't have the recipe in front of you, and you just start cooking, you know, as that recipe gets more and more complex, your ability to keep up and not make mistakes and burn something and things like that starts increasing, or you know, or your ability to keep up starts decreasing, right? You weren't prepared to start solving the problem because you didn't organize yourself ahead of time. This is the computer programming version of that, where we're saying, you know, I'm going to organize my solution now in some different places so that I can focus on one aspect of it in different places. You know, when you're focusing on the sauce for your pasta, you know, you're dealing with one pan that has the sauce ingredients and things like that in it, while maybe the pasta is boiling over in another pot. And eventually you're going to bring those guys together. But right now you're solving them as two completely separate problems. All right, so that's kind of where we're going here. But right now we're playing in this sandbox right here in the middle. We want to get this data right. All right, so we go back in here. We want to think about, actually, I'm going to stay out here for a little bit longer. A JSON file is a single JSON object. That's the contents of a file, a single JSON object. Keeping in mind that JSON objects can be embedded within each other through JSON arrays. So in our world here, for example, a JSON object is a collection of name value pairs, a lot like a dictionary. And the thing we want to focus on here is values can be all sorts of things. They can be strings, they can be numbers, they can be JSON objects, they can be JSON arrays. So you can have a JSON array which holds a collection of JSON arrays, which holds a collection of JSON arrays, which holds a collection of JSON objects, which have collections of JSON arrays in them. You can keep going down to the point where it's probably unwieldy, but JSON is a flexible data representation language like that. So with this in mind, when we are describing our map, we might have a top level JSON object that it looks like this. It's map is equal to, I'm just going to put in the JSON representation of our map. That's the value associated with this variable name. This is my top level object that's inside of my file. It's a single object with a name value pair. The name is map. The value will be the representation of our map. So what does that representation of our map look like? Well, it's going to be a collection of rooms, right? So representation, this guy, is a JSON array of rooms, where a room might look like title, cave entrance, description, pretty dark room. And then we have exits. And what are our exits going to be? This is a JSON representation of the exits in this room. That's what a single room looks like. So now, what is this guy? JSON representation of the exits in a room is a JSON array of exits, where an exit looks like direction, colon, maybe we say north. And destination room ID is equal to, let's say, R2. All right, with that in mind, I actually forgot my destination room ID up here. Destination room ID. We'll call this guy R1. And then, we might have another room that's called R2, so on and so forth. All right, so an exit has a direction and it has the destination room ID. So that when we actually go to build this in our map builder here, as we read in the JSON, once we have all of our rooms, we can go back through and get our exits. All right, so an individual exit is a direction and a destination room ID. That's what that guy is. But our exits value inside of a room will be a JSON array of those exits. And our map itself will be a JSON array of rooms. All right, so if we put all this together, I'm gonna steal some of this code so we can Okay, so part of the punchline here is you are not reading in your file line by line like we did with our proprietary file format. Instead, we're reading in an entire JSON string and then using the JSON library to get the dictionary aspect of that out and walk through that to get our values. So here's our map. This is the JSON objects that are going to exist in there. And we're going to have a JSON representation of our map. So this guy is going to be a collection. So I'll put my opening and closing square brackets in there. And I'll actually kick it down a line. So hopefully it'll read a little bit better, kind of read like code. So inside here, inside of our map, we have a collection of rooms, where we have a room that looks like this. All right, so maybe that's one room. And then I'm going to paste that in and we're going to change this. So we'll call this guy, I don't know, something. We'll call this room 2. It'll also be a dark room and its ID will be R2. And we haven't put the exits in here yet. So right now our cave or our collection of rooms has 2 rooms in it. All right, so we have a single variable associated with a value. The value is a JSON array. That JSON array has 2 elements in it. That's element 1, which is a JSON object. This is element 2, which is a JSON object. I'll go ahead and put my closing curly brace here at the end for the end of my JSON. If you like it better, we can kick it down a line here. JSON ignores white space. So you can even kind of look at it like this. All right, so we have a map whose value is a JSON array that has 2 elements in it. First element is a JSON object, second element is a JSON object, but now we need another level in here. So this guy has a JSON representation of exits in the room. So for exits, I'm going to kick this guy down a line. And my exits are an opening and closing array. And let's just say out of room 1, we have an exit to the north. So we'll go ahead and we'll have a exit in here. So we'll have direction to the north. And we'll have destination room ID will go to R2. Let's say that's where that exit goes. So the collection of exits for this first room in our cave has exactly 1 exit in here. It's still a collection. This is like a list with 1 element in it. Okay, so it's a collection of exits with 1 exit in there. An exit is a JSON object that's keeping track of 2 pieces of information, a direction and a destination room ID. Similarly, for our exits associated with our second room, we'll have a exit going back to the south to room R1. All right. So this ends my collection for exits. This ends this JSON object. So this is a JSON object. This is a JSON object. Those guys are in the collection of rooms that are associated with our map. So what I'm looking at right here is a single JSON object with a single name value pair. Okay, so its name is map, its value is a JSON array. That array is a collection of JSON objects, which are our representation of rooms. Here's our first room. Here's our second room. A room is a collection of name value pairs where we have title, description, destination room ID. Actually, hold on. This guy's not called destination room ID. He is called just room ID. Make sure I'm giving this to you as accurately as possible. So a room has a room ID, an exit has a destination room ID. So this room has a title, a description, and a room ID. And then it also has a collection of exits. So this is a name value pair, this is a name value pair, this is a name value pair, and this is a name value pair. Its name is exits, and this should be in double quotes. And its value is a JSON array. It's a JSON array of JSON objects. And these objects represent an exit. An exit has a direction and it has a destination room ID. Okay, so this particular room only has.
Question.
What? Alexa, shut up. I don't know how I triggered it, but I did. All right. So this guy is our collection of exits for this first room, and there's only 1 exit in here that's heading to the north to room 2. So this in its entirety describes a single room and all of its exits. This guy in its entirety describes a single room and all of his exits. This guy describes a map and his collection of rooms. So when all is said and done here, this is a single JSON object. This is a name, and this is its value. We could have other names and values in there. We could have a number of rooms is equal to 2 if we wanted to. If we wanted to have a second value associated with that object, we can do that. Now we have 2 name value pairs. We have map is equal to this collection of rooms, and then we have number of rooms is just equal to 2, a simplified value type. All right, so this is an example of what your JSON file might have in it. Yours might be larger for larger rooms, or for a larger number of rooms. I've only created 2 rooms here, okay? But this guy right here is what would live inside of this JSON file. And we can either write it by hand like we just did, or we can have a computer program that generates this for us. It doesn't matter, one way or another, we're gonna get something that looks like this, that has to be properly written JSON. Now, when we read this in our program over here, we should be able to turn this guy into room objects, exit objects, room objects, exit objects, and ultimately the whole thing is a map. Now, we don't have a map object, we actually have a map builder. So the map builder would parse this JSON here by doing a load S. It'll load this string, or a load if you're loading from the file. And then that will give him a dictionary with a single key in it, a key called map. And that guy's value will be a list. That list will have 2 elements in it. 2 dictionaries is what he'll have. The first dictionary will be our name value pairs for a room. The second dictionary will be our name value pairs for another room. So we would go through there and create 2 instances of rooms. Each one of those guys will have a list of exits, where exits are represented as a dictionary. All right, so this is what we're targeting for this center guy. And what we're currently working with here is updating this program to read something that looks like this in from this file and turning it into our rooms and exits that our player can walk through. All right, so hopefully that kind of clarifies what our target is for this JSON file, and I hope that kind of answers several of the questions we've gotten. So are there any questions about any of that that I can clarify before you go back to work with your assignment if you want to work on it some more?
I have a question.
Mm-hmm.
Could you go back to the example that you made, please? Does it have to be in this format with all the spaces between everything, or? No,
I just wrote it like that to keep it, a little bit clearer to read. You could have this all in one big long line.
Okay. Thank you.
I kind of wrote it like a program with indentation and stuff, because really JSON is the JavaScript object notation for the JavaScript programming language, and Python forces us into indentation. A lot of our programming languages do not. So JSON does not require us to do all this indentation stuff. I just think it looks a little bit more like code to us if we write it like this. But if you want to throw it all on one line, have at it. It's just a little bit harder to debug, I think.
Okay, thank you.
But if I throw one more thing on there, if this guy is building that file and you're never actually intending to write it by hand, who cares? This guy's not going to make mistakes. He's going to be able to write this all on one line without going insane. All right, any other questions? Okay, and like I said, no homework over the weekend. Hopefully you can get caught up on some stuff, or I know there's some tests and big projects coming up in your other classes, so I want to give you a little bit of reprieve in this, because I know people are spending a lot of time on their homework during the week, and I think we'll do the same thing for next week. We'll have our assignments in the week, and then I'll give you the weekend to reboot. Otherwise, I will see everybody on Monday.